Hi guys, we are going to start chapter 2. We'll get through it pretty quickly because it is more or less what we just did, but with inequalities. We have all the tools and skills that we need to solve inequalities. And you may have uh, last year you may have done a lot of this. So we're going to start with writing and graphing inequalities. And within a couple days, we're going to get through, probably not even, maybe a day and a half, we will get through all of chapter 2, or most of chapter 2. And just kind of prepare yourself. We'll have a review and we'll have a test sometime next week. So I figured this would be a good opportunity for me to make a video and just kind of that way you can pause, take notes, and we can get through this material even faster. So an inequality is another way of comparing numbers. It's a math sentence that compares expressions. These are our inequality symbols. So get familiar with the phrases that are associated with them. The ones that we are that were most commonly used, the one that we use the most are for this first one is less than. Okay, but it also could be is fewer than. Those are the words that we could use instead. This symbol is greater than or is more than. This symbol is less than or equal to. It could be referred to as at most or no more than, and greater than or equal to is at least or no less than. So we'll start with, we're not going to do all of these examples, so you only need to write down the ones that I do. Oh, and I forgot to mention that since we are starting a new chapter, make sure that you put this in your table of contents and the appropriate page number that goes with it. So for the examples, let's just start with the first one. Number W minus 3 is less than or equal to negative 2. So a W minus 3, telling you to subtract 3 from it, is less than or equal to. So less than or equal to is the symbol right up here. And is less than or equal to negative 2. It's not asking us to solve. That's all we have to write. 0 is greater than or equal to twice a number. I'll say 2. Oh, they tell us which variable, 2x plus 1. There's our inequality. A number B is fewer than 30. So B is fewer, which is less than 30. Next. Oh, excuse me. A solution to an inequality is a value that makes the inequality true. So we can have lots of different solutions for an inequality. And the set of all the solutions of an inequality is called a solution set. So for this example, this is our inequality. X plus 5 is greater than or equal to negative 2. And we can test different values to see if these values make the inequality true. So when you plug in negative 6, you just simplify that left side. Negative 6 plus 5, that's negative 1. And you're asking, is that greater than or equal to negative 2? And that is true, because the more left you are, the smaller the value, the more negative the values get. So negative 1, since negative 1 is to the right of negative 2, negative 1 is bigger, and therefore that makes the inequality true. I always like to think about, again, money. I know I talk about, like, when we're adding and subtracting negative numbers, I always talk about money because we understand that. Would you rather owe $2? Would you rather owe $1? Well, both aren't ideal, but it'd be better to owe $1 than it would be to owe $2. Similar idea here. When you plug in negative 7, you get something, you get makes the inequality true. Negative 8, however, does not. Negative 3 is not greater than or equal to negative 2, so that would be a no. So we'll just do a couple of these. We're going to tell whether negative 4 is a solution to the inequality. So we plug it in. So we'll just do the second one. So be careful that it's 3 minus m. We're going to replace -4 with m. And so it should say 3 minus -4. When we take a negative and a negative together, that makes a positive. And we have 10 is less than or equal to 7, which is not true. No, it is not a solution. And similar cases, we would just plug it in and see if it's true. Graphing inequalities. So the words we would use, x is less than 2. Here is the inequality in algebra, and this is our graph. So we would draw a number line. When we draw number lines, we don't need to write, 6, 7, 8 numbers. I'm okay with 3 numbers. I'm sure I will get to an example where I draw an inequality, probably in the next video. So if we're looking at x is less than 2, then we have an open circle around 2 and we shade to the left. The open circle indicates that it's not including 2. Let's actually jump down to x is less than or equal to 2. So less than or equal to 2 means that we're including 2, and that's why we use a closed circle. So the less than or equal to and the greater than or equal to make a closed circle. Going back up to x is greater than 2, open circle at 2, and we're shading to the right because we're looking at all the values that are bigger than 2. And then only difference with x is greater than or equal to 2 is that we have a closed circle on 2, and we shade to the right. I'm going to graph each inequality on the number line. So find the value in question, so -3. And this one's going to be a closed circle because it's less than or equal to. Just refer to the chart above. And we're shading, you have to think about we're shading to the left or to the right. Well, this means that all the values of y should be smaller than -3. This is saying that the biggest value that we should have is -3. So all of the values to the left on the number line of -3 are going to be in our solution. Make sure that when you draw your solution or you shade your number line, that you also include the arrow. If you don't include an arrow, it's not correct because you're saying that your solution ends at some point. So the arrow means that it goes on forever. Let's skip down to this one. To me, it's easier when the variable's on the left side. So to flip it around, just think about you probably remember some of your middle school teachers talking about the mouth of the gator, maybe even late elementary school. So the mouth is opening towards the x. So when we rewrite it, it should be facing the same direction. These two things are not in the same direction. It should be opening towards the x in both cases. So these two things are the same. And we would, to graph x is greater than 2, open circle around 2, and to the right. Writing inequalities, we're just flipping the direction really. It's wanting us to write an inequality that represents the height restriction of each ride. So if you think about a theme park, they actually do have these where you have to be at least 48 inches to ride most of the bigger rides. So your height, if it's including 48, greater than or equal to 48. Ride B, this is probably a little kid ride. So the height of the individual has to be less than 52 inches, not including 52. So H is less than 52, where this means that 52 is, well, not including 52, but up to 52 inches. Those are the people that can ride the ride.